So at the top and in the middle, I would like you to write perfect squares. So in our first color, what we're going to do is we're going to write our counting numbers. And remember, counting numbers are how you count, correct?
Yes.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Thank you, Marshall. 13, 14, 15, 16, 17, 18, 19, 20, and I'm doing 21 because I don't want my columns to be uneven because I'm a weirdo. So in our next color, what we're going to do is we're going to square those. So I'm going to use green. And the reason that we're doing our perfect squares is because we're going to practice breaking down radicals today. So what's 1 squared? 2 squared? 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 49. 8 squared? 9 squared? 10 squared? 11 squared? 12, 13, 14, 15, 16, and then 289, 324, 400, 441. 21 squared is 441? Okay. Thank you. So I want you to know 1 through 20, but if you know more, that's good. Yeah, we may do that.
Yeah. May do what?
So, from yesterday, who can tell me one thing we learned? Raise your hand, not scream at me because I kind of got a headache. Christine. What's the radicand? It's under the radical. Awesome. Take a point. What's another thing we learned? Fan?
The index.
Where is the index?
It's in the square. It's in the root.
Which part of the root?
At the top. Like inside of like at the top.
So, if I wrote a root like, here's scratch paper, Blair. If I wrote a root like this, is that my index?
Yes. No. What?
It's up here? It's in the mullet.
Yes.
Okay, take a point because your team helped you get there. What's another thing? You've already answered. What's another thing we learned? Kalia?
But if there's not a number outside of the root, you want it's the square root.
Yes, it's a 2. It's a square root. Thank you. Take a point. Christine, you've already answered.
But no one else can.
Okay, tell me. Is it one more time?
Rational exponent.
What is rational exponent form?
Exponent is like exponent E over I, right?
Fantastic. Take a point. It's when you have a fraction as an exponent, right? So, what we're going to talk about today is we're going to talk about how to break radicals down, how to simplify radicals like this. Now, we struggled a little bit last period, but I think it was my fault more than theirs. So I'm going to try and explain it differently. It's really more that it's not something that's just a gimme. You're not going to automatically know this. You're going to have to think, and Heaven forbid you guys have to think. So what we're going to do is you're going to have your card, your index card. So you're going to need this today. And we're going to write on the back of page 45C. So on the back of this, we're going to write our problems. We're going to start first, and I don't want you guys to write this. I want everybody to just look up at the board. If I say that I'm looking for the square root of 25, what this means is that we need two of the same number that multiply to get us 25, right? That's what we're looking for. We're looking for two of the same number. So what two numbers multiply? Avery.
5.
Okay, now, does everybody see how I have two of those?
Yeah.
Do you guys remember doing factoring trees? I know, this is so difficult. Let's moan and groan like I'm murdering your whole family. Now, what is the square root of 25? 5. Because we have two of the same number. We don't have a number right here, so it's understood as a 2. We write 5. Is everybody with me? Okay, now what if I wrote the square root of 75? Is 75 on our list, on our green numbers?
No.
Okay, now what you have to do is you have to find the biggest of our green numbers that goes into that. So let's start here. Does 64 go into 75? Oh my mama, oh my mama. 75 divided by 64. Does it go into that? No. Y'all, I divided. Does it go into it? Does 75 divided by 64 give you a whole number?
It's 25.
Okay, why do you pick 25 and not 36?
25, we have 3 of them, so no, you only have 2 numbers.
No, I want you to tell me what you were saying, Ben. I don't want you to listen to anybody else. I want you to tell me what you were saying. Why did you choose 25 and not 36? Look at you go. 25 times 3 gives us 75. Does everybody understand? Now, we have a perfect square and another number. What does 25 break down into? Do we have two of the same number? What's the square root of 25? What is left over? That stays under the radical. I didn't explain it like that last period. I tried to jump into it because I thought you guys had done this before and that we knew how to factor and that we knew we have done this before. You have done this before. You have. And I expected you to be able to retain knowledge, and I just didn't explain it well, so it's my fault. Right, y'all been doing this for a while. Okay, so let's talk about 125. What's the biggest perfect square that goes into 125? 25 times what?
5.
Okay. Now, can 5 be broken down by a perfect square? No. What is the square root of 25?
5.
That's your answer. All I did was take the square root of 25. This guy is left over, so he stays under the radical. What's the square root of 25? 5. That's why it goes to the outside. Yes.
So, like, if you had to break, like, if it was another number, like, other than 5, how do you determine which one goes in the radical?
The one that's left over. So if I said, I'm not slamming this at y'all, I'm thinking. If I said, 384. Okay? So we're going to take the square root of 384. Now let's look at we're looking at the green numbers. We're using perfect squares, not the counting. What's the biggest number that goes into 384?
61.
Okay, so you guys, please do 384 divided by 361. Does that give us a whole number? Oh, I did times. No. So that doesn't work. So we need it to go in there evenly. We're breaking it down into the factors. So pick another one. 16? Okay. So if I did 384 divided by 16, we get 24, right? But is there a perfect square that goes into 24?
6.
Well,
4.
4. Yes. 4 goes into 24. That's the biggest perfect square that goes into 24. So we need to find the bigger number. So go bigger than 16. Let's find a bigger number that goes into 384.
24.
Guys, take your green numbers and divide. Yes.
64?
Yes.
Yeah.
Okay. So if we did 384 divided by 64,
6.
No. Why couldn't you use 24?
it's not a perfect square.
Oh, you're looking for it to
Again,
be on the green?
we're looking for green numbers.
Okay.
Now, Yasmin, the reason that we did, I'm going to use yours in just a minute. You're 16, because that's still right, but I'm going to explain it in just a minute. Now, what does 64 break down into? 8 and 8. We have the same number, right? So what comes to the outside? 8. What stays under the radical?
You don't break down anything.
Because we have 2 of the same. Now, Yasmin said that we could do 16. And you would have 16 times 24, which is right.
But that's a lot of breaking down.
What does this break down?
8. 4.
4 and 4. So the square root of 16 is?
4.
Okay. Now, there is a perfect square in 24. It's 4, which would be 4 times what?
6. I thought we summed up like
All right. What's the square root of 4?
2.
And what's left under the radical?
6.
What's 4 times 2?
8.
Oh, this is got us there.
It did. Now, do you see why I tell you to take the biggest?
Yeah.
Go with the biggest each time, because we're trying to find the biggest perfect square, the biggest green number that goes in. Do not use the red numbers. That's what happens if you take the square root of 289. You get 17. That's how you go backwards. Does everybody understand?
Yeah.
Are we sure?
Yes, ma'am.
I'm seeing some faces that aren't even registering what's happening. So that's exciting.
Is there another way to do it, like, without guessing? Like,
Know your multiplication tables.
like,
Know your multiplication tables. Yes.
Can you plug that into the calculator, like 8 to square root of 6, and so you get 3?
Yes, but if you plug the square root, okay. So second square root of 384 is 19 point that. Okay? So if I did 8 square root of 6, oh, Blair, you didn't do it. 8 times second square root 6. Same thing.
one of the most
That's the way of thinking.
Mhm.
Oh, it's like instead of running a decimal, it's kind of a fraction, but it's not. a
Yes.
fraction.
And you don't ever write these as decimals. These become irrational numbers, so you leave it like this. All right, are we ready? So what we're going to do now is we are going to break these down. And we are only going to break down the one with the squares, okay, or with the square root. So we're going to start with 24. So everybody write it on the back.
on the back of the sheet.
45D, yes. Number 1 is the square root of 24. Now, what is the biggest perfect square that divides evenly into 24?
4.
And it's 4 times what?
6.
Okay? Is everybody with me?
Yes. Senior. Yes.
We're not with me? Do we understand where I got 4 and 6 from?
Yes.
Does anybody not? All right? 4 is the biggest perfect square that goes into 24 evenly. What's the square root of 4?
2.
So this becomes 2. What stays under the radical? That's it.
Wait.
It's not hard. I mean, it's like, it doesn't seem hard.
We broke it down a different way this time than I did last period.
Can you show me how you did that?
No.
Is it really hard?
No, it's the same thing. I just started off doing this and not breaking it down on the paper like that. It's okay. We all learn differently. All right, you guys ready for the next one? Any questions on this? Are we sure? Okay. The next one is 512 times x squared. So it's the square root of 512 x squared. Now again, we need the biggest perfect square, the biggest green number. Blessings.
Is it 64?
Bigger. Because if you do 64, if we broke 512 down by 64, we would have 64 times what? 8? What's the perfect square that goes into 8?
2.
256.
Yeah, and it's 2.
Alright, so then it's 256 times 2. Does everybody see where I got that from? Okay, I found the biggest one. So I started on my larger end. Because I have a big number under here, I started over here. And at first I did I think I did 324, and I was like, no, that doesn't even make sense. And then I came back over here, and I did 36, and that didn't work. I did 64, but it came out to be 64 times 8. I know that there's a perfect square in 8, so I went bigger. You could also break it down and do 8 times 2 gives you 16. Squared 16 is 256. So I went bigger after 64, and I just started plugging in numbers and dividing. Now what's the square root of 256?
16.
Okay. Now, do you guys see this x squared?
Yes.
How many x's is that?
2.
So if I take the square root of those, what's going to be on the outside? X. Square root 2. That's it. Alright, where are we confused? Where do we not understand?
I think the X part is kind of
Okay, well you see how there's 2 of these? And you see how we had 2 of these? We took 1 to the outside of the 16, right? It's the same thing. We're not there yet. Does everybody understand? Now, this is not something that you're just going to automatically know. This takes practice. So if you don't get it right now, that's perfectly okay. We're going to keep practicing. So what if I wrote just 512 with no x?
256. And then 2 will be on the inside, and then 6.
That's it. So, do we have any questions on 1, 2, or 3? And if you do, you need to speak now before we move on. And it's okay if you have questions. Like, we need to get it out now and talk about it. So we're all okay. Okay? Then you're doing the next one without me. Square root of 98k.
I feel like I don't know what I just.
Okay. Well, how about you try that one without me? Talk to your group, man.
I got it.
Are we ready? Some people said they're not.
I got that, but I'm confused. I got 7 kids and 2 of them.
What is the difference between this variable and what we had up there?
It doesn't have an
Right.
exponent.
So if there's just one, we can't take the square root of it.
Okay, that's
It
right.
stays.
It's not.
We can't bring it to the outside.
So it's just 7 and then 2 of this. That's it.
And what else stays on the inside?
Okay.
Because you can't take the square root of it. Because there's only one, right? So you see how you had only 1, 2 when you broke it down? Same thing. All right, y'all ready now? Okay, what did y'all get when you did 98? 49 and 2. And then what's the square root of 49?
7.
Okay. What stays under the radical?
2 and K.
Now, what's the difference between k and when we did x squared?
That's not greater power.
There's only one. There's not an exponent. So we had 2 x's here, so it came to the outside. You see how we have 1k? And we had 1, 2? Stays underneath. Yes. Part of them can. Not all of them. Yes, when it's an odd number of friends, they can't all go outside. All right, y'all ready for another one?
Yes.
Okay. Let's go crazy? All right, let's do this. All right, 128. X to the 4, Y to the 6. All right, let's not whine. We're not whining. We're not being babies. It's not even that crazy.
Okay. Whoa. I heard her when she was talking, but he got it though.
I know. It's 2 letters and 3 numbers and some exponents. What will we do?
Ever. Yeah. That's what you're saying.
He's not about that life. He's not going to say it. Keep whispering over there, Van, like I don't hear you, son. Try me, baby.
No, it wasn't about you. No, I wasn't. Okay.
Jasmine, are you just not doing this?
I'm looking at my calculator.
No. Talk to your group. No.
I'm
Talk
done.
to your group. I know I'm the devil. Talk to your group. No.
I know.
No. No. Talk to your group.
They're not doing it.
Talk to them.
I said I need.
No.
I can't tell
No.
if I'm right.
No.
If I'm right or wrong.
No. Woo. Y'all ready?
Yes. Please check mine.
Okay, there's this video of this rapper and he's being all crazy and he does this thing and he goes, and we just like not even give him
What?
So what I'm going to do is our timer from now on.
Please check this.
No. When you broke down 128, did you get 64 and 2? Look at us go. Okay, so what's the square root of 64?
8.
All right. Under the radical is a 2, right? Okay. How many x's do we have?
4.
So how many would we bring to the outside?
1.
2. It would be x squared. Alright, how many 3. So how many we bring to the outside?
Oh, is that? What's that? 128. I'd rather go.
Alright, now I'm going to break down the exponents. Did anybody get that right?
I didn't put 2 in the inside. I put C because I was thinking I was gonna add the X.
You can't do that.
I didn't go over there.
I was close.
Okay, you were close. Alright, so x to the 4th is the same thing as saying x squared times x squared, right? How many of those do we have? 2, so we take 1 out. Y to the 6th is the same thing as saying y cubed times y cubed, because you add those, you take 1 out. Also, this is a little 2, right? 2 goes into 4 how many times? 2 goes into 6 how many times? Look at us go.
Wait, okay, I get the Y squared, or the X squared.
Okay?
I get the Y cubed.
Okay? This breaks down into y cubed, times y cubed. 3 plus 3 is 6. That's why that works. When you multiply like bases, what do? You add them. Yeah.
Okay.
Alright. Una más like this, then we're going to talk about homework. Y'all ready?
Yeah.
Girls, please don't make me separate you. Did I ask you if you did anything? Did I ask you if you did anything? Alright, let's do m to the 5th, n to the 7th, p to the 9th. We're going crazy. Ignore my little hooks. I thought I was going to end it and then I didn't. Oh my gosh. I know, we added one more letter on there. Yasmin, I've got to bring you my glasses or you're going to have to look at the person next to you, paper or something, because you hurt my soul when you squint up there like that. I feel so bad. Yes. You can't see. Yes. Y'all do know I also say what I write?
Yeah, but I'm be listening because then my brain goes.
You don't be listening.
No.
Awesome. You're going to do great in life.
I know. Once we get it saved in here, I come. Y'all remember when we were in Meadowview?
You remember when you did your work quietly? Me either.
I can't think like that. I gotta have no.
No.
That's how it is. I have to play dorms. That is so great. Have you ever heard
Ah, that's exciting. No. No. No.
Okay, never mind. I think I got it.
You can do it. I have faith in you. Okay. If they're even, well, you think of how many times 2 can go into 5. And then how many would be left over.
Wait, you said if it's odd, they can't
So,
count.
it can.
They can?
So you would have, it can go into it twice with 1 left over, right?
No, she's talking about the room.
So it would be broken down as m squared times m squared times m. So how many m squareds do you have? You would take 1 out and you would leave that m underneath. I'm going to show you in just a minute.
Does it always have to be by a 2?
Well, with squareds, it does. We're going to break it down into cubes and fourths tomorrow.
And how come the first one is a 4 and a 6?
Because 4 is a perfect square. You're meaning 2 with the exponents. That's completely different than with the coefficients.
I think I did it right.
You see what I'm saying?
I'm gonna come in here and change girl for it tomorrow. I'm like the big right now and like
Okay. When you get some sleep, it might help.
you can see.
But why are you so tired? Okay. So we'll just try again tomorrow. Is that our goal? Okay. All right. Did you guys get 49 and 5?
Yes.
Okay. So then you have 7 outside.
Yes.
Okay. Now we're going to break down this. How many times does 2 go into 5? Twice. With how many left over? Okay. So it would be m squared. And then underneath our radical, we're going to have a 5 and an m. Okay, that 5 comes from there, and the m is what's left over, right? Okay. How many times does 2 go into 7? With what left over? How many times does 2 go into 9?
4.
With how many left over? That's it.
Raspberry.
Yes.
I almost had it, but I didn't do like the 2 and stuff, so I was just like,
I wasn't saying
8. I don't, sorry. I was just saying like 8 on the outside and then 1.
You have to divide.
Wait, how? But how
Julia,
did
does that
just-
make sense where I said,
Why do
okay,
you use 2?
because what is this? What's our index? 2. When there's not 1, you use 2. So 2 goes into 5 twice. That means you're going to have 2 m's out here with 1 left over. 2 goes into 7 3 times. So you're going to have 3 out here with 1 left over. 2 goes into 9 4 times. 4 out here, 1 left over. You divide. All right, are you ready for your homework? So on your, okay, Avery, what don't you understand? I'm sorry?
I don't know. I think it's maybe the dividing part. Because sometimes I'll get it, like the big number. Sometimes I'll get it, but like this, I was thinking we divided by 2 to get the.
This number right here?
Yeah.
Okay, don't confuse the dividing by 2 here with dividing by 2 on the exponents. The coefficient is your perfect square.
Yeah. I mean, like.
The exponents are 2. Okay? So here you use your perfect squares, which are these guys. Right? Here you use 2 because of the index. That's a totally separate part. So don't worry about those. Break this down first using your green. Alright, your homework tonight is this sheet that you got yesterday. You're going to do 1 through 10 tonight. 1 through 10 tonight. You may start. And you're going to write your little baby answers up here.
You want us to
Raspberry.
Yeah.